Okay. What we left off with on yesterday's class was we were talking about looking at Amazon and how all of that stuff is set up. And we made a diagram, and we were talking about what do the classes have together and what's their relationship and all that different kind of stuff. I went and I revised the diagram and just refined it a little bit. So I thought I could first review with you where we left off yesterday. I guess I should give you my screen so you can see it too. Now this worries me. If you look at my screen for Van, I don't see any computers or anything. Let's see. All right, so we left off with this diagram, and I thought maybe we could start by reviewing some of the relationships between these 5 classes. First one, what's the relationship between store and item for sale? Store has items for sale. Very good. What's the relationship between a book and an item for sale? A book is a item for sale. What's the relationship between an author and a book?
An author is a book.
I think it looks like what I see is
sorry.
Go ahead. Yeah, fix it.
Sorry. Author has a book. I didn't realize the direction this was going.
I think it's one more time around. I think book has an author. Because if you look at the instance variable for book, everything you see with the plus sign is an instance variable, by the way, the name of the instance variable, and then after the colon, the type. So I would say book has a author. And then lastly, what's the relationship between movie and item for sale? Is a. Movie is a item for sale. What's the relationship between author and movie? No relationship. No relationship. So this is kind of where we left off. The activity, just as a reminder, I just pulled it up. We're not actually going to program it on the website, but it says use the code window below to declare each class and specify the relationship to one another with inheritance or association. Note that usually each public class would be in a separate file, but since we only have one file, blah, 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 we can only make one class public. Only put in the instance variables for each class. We will learn how to make constructors and methods in the next lessons. So right now we're just doing instance variables and setting up the relationship between them. Instead of you guys programming in the active code window and people complaining about the formatting and yada yada yada, what I did instead is for you folks, because I love you, I made a starter code file for JGrasp. So I'm going to go ahead and click on it, boink, and I'm going to go ahead and copy all 0.3 kilobytes of it, 25 lines, boink, and I'm going to paste it into a new JGrasp, boink. Now, what you are going to do, and I know it's very awkward to have a bunch of classes in the same file. I just explained why they're all there. It's just so you can see all of them in the same place. It's not typical. But what you're going to do is add in the instance variables for each one of these classes and describe the relationships between them. If you try to compile right now, it'll save, but it's not going to compile correctly because there's some issues. You haven't finished writing the code. What I would do if I were you, to simplify my workflow, I would take JGrasp, I would snap it to the left side of the screen, and then my right side of the screen would be wherever I have that diagram. You're not going to need my screen for like the next 10 minutes because you guys are going to be doing this on your own. I'll help you get started though. For example, the items for sale class. If I'm looking at this diagram, it says items for sale has a instance variable title, which is a string. That's how this is read. So I would say something like, well, all instance variables are private, so I'd say private. And then what's the type of title? Well, it says it's a string right there. And then what's the name of this instance variable? Title. And I know in the diagram it shows a capital T, but you guys weren't born yesterday. You know not to make your instance variables start with a capital letter. So that's where I would start with item for sale. And then I'm going to do the same thing for the rest of the classes and their instance variables. and there's some things you have to watch out for. There is an array list. I said a store has an array list of items for sale because after you sell something, you remove it. So instead of making an array, I'm making an array list for item for sale. You got to be careful if you include an array list. You also have to be careful about how you set up the inheritance relationship between book item for sale and movie an item for sale. How are you going to say that a book is an item for sale? How are you going to say a movie is an item for sale? That's something for you to think about. Right now it's about 1:50. I'm going to say at 2 we'll go over solutions. I'm going to be walking around circulating and helping you folks accomplish this. Have every single instance variable and every inheritance relationship and composition or association relationship set up in the next 10 minutes. I'm going to walk around and help. Yoink. Ding, ding. Okay. Is that recording? Perfect. So, up at the tippy top, I imported the array list class, so I could actually use an array list. Great news, you would never have to do that on the AP test, but it was a good review, hopefully, for you, remembering that array list isn't built into standard Java. Notice that item for sale, I don't say it's extending anything because an item for sale is not a movie. The relationship does not go both ways. Item for sale cannot be substituted in for movie. Movie could be substituted in for item for sale. So that's why you see item for sale extends nothing there. But what's it technically extending? Object. Very good. A movie is a item for sale. A lot of you eventually did catch that. That's great to see on day 2 of inheritance. Very nice. I guess day 3. And book is an item for sale. So the way we say a book is an item for sale is we say book extends. And then an author has a first name and a last name. Sure, you could have put them on separate lines, but since they're the same type, I just declared them on the same line. A store has a store name and an address. Oh, you know what? Let me go back to book for a second. This is composition right here, or this is, you could say, association, or this is the has a relationship. Here you're saying a book has a author. This kind of got some of us, but it's really not a new concept. Let me just say for a second, what if you had a class person and a person has a name? Well, we don't act like that's strange. Isn't that also a has a relationship? A person has a name. A book has a author. It's just strange for some of us because this type is not defined in standard Java. Okay? So that did catch a couple people, but you know what? I think if you make a small mistake, then you probably learn from it. This is not a string. An author is a author. It's defined down here. Then for the store class, the store is supposed to have a store name and address. Look, here's has a, and then also it has an array list of sale items. I did catch a couple people trying to instantiate that array list. That's typically something we would do where? In the constructor. This is, didn't we do that for the lights question the other day, right? Ben, yes.
Yesterday for the has a relationship.
Yes.
We use an array next to the object. Why do we not say?
For the has a relationship, I think you can use with the author. I think you could go in any direction you want to. Really, I just changed it to an array list of items for sale. I was just thinking that after you sell an item, maybe it gets removed from the items for sale. But really, you could. That's a great question. You could really use any type. You could use an array list. You could use an array. In fact, like the person object I just brought up, you could just use a string. Like for example, author has a first name and last name. Composition is just the idea that you're using another class's object as your own instance variable. Does that kind of make sense? Or I just kind of changed around what I chose for the instance variables, I guess. Yeah, Jason.
So, like, how would you instantiate the private array list? Would it be just like new array list?
Yeah, so if there were a constructor for store, let's just ignore any other parameters. It would be like sale items equals new array list. And there's a couple options. Option 1, option 2, and the option I would choose Any one of those would be okay inside of a constructor there. That's how I would do it, but technically, since you would have the type operator already declared, you could just leave it like this, or you could even put in empty type operators on the right if you've already said what it's going to hold on the left. It's confusing. I just always put the type operators on both sides. Yes, Ella?
For this array list, why are there any parentheses?
So that's a great question. So right now I'm just declaring it, and then what I would do is there's only going to be parentheses when I actually go ahead and instantiate it. So then I could add stuff to it. So that would be like inside of stores constructor. Then I would go ahead and have parentheses to actually instantiate it. It's just because I'm only declaring it now. I would save the instantiating for the constructor. Great questions all around. Ben and Jason and Ella, and if I missed anybody, great questions. Anything else? I wanted to show you one thing. You don't have to do it on your computer, but sometimes I like to show people the JGrass visualizer. It's kind of cool, at least for me, at least here. At least. If I go ahead and click on this gray thing, it puts a little stop sign in, and then I can hit this ladybug, and it'll start up what's called the debugger, and I can actually see what is going on in my program's data and its memory right now. And I thought it'd be interesting for you guys to look at the book and movie class. Here's the book that I created. I created a book object B on line 29. You guys can see it's right there. What instance variables would you expect a book to have? Author and publisher. Where do title and genre come from? Yeah, isn't that pretty cool? It even shows you with the JGrass visualizer. It shows author and publisher in green. Those are instance variables that came from the book class, and then it even says title and genre, declared an item for sale, declared an item for sale. I thought that was pretty interesting. Hypotheses here before I show you movie M. What instance variables is movie M going to have? Title, genre, and rating. Title and genre come from the item for sale class. It even says item for sale, declared an item for sale, and then the rating comes from the movie class. So you can kind of see that inheritance happening live in front of you. Yes, Jack? Yes, it's like we just have them, even though we don't see them in the class. That takes one step ahead to where we're going to be tomorrow when we look at writing constructors for our subclasses and superclasses. But for right now, the main important thing is you understand that we inherit them. We get them from the parent class. Yeah, Max?
Class and call it the Hobbit, and then you give it the variable pages, and then you look at this and have make an extension of the book, and then would it have all title, genre, author, number of pages?
Can I back up one second on that question? I don't think you would make the Hobbit extend book. I think you would probably say the Hobbit is just a book, like the Hobbit is a book object. Because the Hobbit is a instance of book. If you were going to extend the book class, maybe you'd do like a comic book extends book. Or something like... Say,
Also include the item for sale.
yes. So now I understand. So like if we made, so let's just in our heads have another hierarchy. Let's say that there's like class comic book extends book. That's what you're saying basically, right? And so in this hierarchy, it would essentially look like item for sale is up at the top. And then what is an item for sale? Well, a book is an item for sale. And then what is a comic book? A comic book is also a book. So a comic book would have, what was it again, title and genre? Comic book would have those because a comic book is a item for sale. So it kind of, it's kind of, does that answer your question first of all? And it kind of goes up that structure again like a hierarchy in biology. All animals have something in common, then all you're just specializing as you go down the row. You're generalizing as you go back up the column, I guess I should say, the hierarchy. Great job. Any questions? Are you guys doing okay? We're doing all right? I do care about your well-being. I'm just checking in. It would be kind of nice to have a day off tomorrow, wouldn't it? How am I doing? I'm doing okay. I'm having some back issues. I have to go get an epidural. And do you know what an epidural is? Like, sometimes women get those when they're giving birth. I have to have one directly injected into my back, steroids. And that's just to prepare for a surgery I'm going to have in April. So, other than that, it's going okay. I thought the Super Bowl was kind of a crummy game, so there's also that. Say it again?
YouTube heard it first.
YouTube heard it first, yeah. Yeah, and now, like, everybody that's watching this video is going to be sending their spirit energy to that snow day tomorrow. So, 1,000 likes equals a snow day? I don't know. We'll see. No, I'm just kidding. I would never do that. All right. Yeah, I'd be lucky to get 1 like. Let's be honest with each other here. Okay. All right, yeah, the ratio's not going so good. Okay, let's keep going here. All right. There was an article about how some like famous YouTuber publicly like faked his girlfriend's death, and then she's not dead. Good. Good. You know what? You're probably a loser if you get broken up by your dead girlfriend. Can I say that?
Whoa.
She wasn't really dead. People that are listening, she wasn't really dead. It's a fake. All right. She wasn't really dead. He was faking it. I'm not going to fake anything on YouTube. I promise. We need to learn about a special keyword in Java called this. Some of you, it's a relatively short lesson. Well, let me say it this way. It's a short, small thing to get, but I need to talk about it a little bit. Some of you might want to add to your notes about this. You could probably just add to the notes that we've been already creating. You don't have to, but I would recommend it.
Is this hard?
This. It's called this. So this is real. Y'all ready for this? Why didn't I?
That's copyright.
I'm gonna get content ID matched. Okay. Let me think about how I want to say this. So, we are talking about inheritance. Today and yesterday, the day before, we talked about how you get all the instance variables of the parent class. There's something else that was buried in the lesson. What else do you inherit? Does anybody remember? Not just the data, but you also can inherit methods. Very good. You can inherit abilities. So here's where things can get a little bit confusing. Your parent class might have a method, and then the subclass might also have the same method. And if you inherit that method, how do you keep track of, are you talking about the parent class's method, or are you talking about the subclass's method? It can get very confusing. If you don't understand what I'm saying, let's say that, in general, let's say there's a public class mammal, and in that mammal class, there's something like public void give milk. And in general, mammals give milk in some way. Okay? And then maybe you have another class, public class primate, that extends mammal. Well, what if in that class you have a method public void give milk? Why? Because mammals give milk. So the primate class will get the give milk method from mammal, but then the primate class also has its own give milk method. So how do you know which method you're talking about? Well, the keyword this is going to help us specialize which and differentiate which methods and which variables we're talking about. There's a quick video I want to show you. But here's the issue. If I put a video on, it crashes Vayon, unlike usual when Vayon works perfectly. So I need to stop Vayon for a minute, stop recording this whole section because we're talking about inheritance. Classes inherit. So some of us need to review stuff about classes and objects. Some of us might have not been very good at it in the first place. This is an opportunity to review. It says when we create an object, the object name reference is created in a class other than the objects class. So usually we have some like tester class that makes the objects, and then we also have the class that defines. So we'll have like class rectangle, and then we'll have a rectangle tester class or something. We can create many objects from the same class. Remember, it's like cookies. One cookie cutter, many possible cookies. One class, many possible objects. How does Java know which objects, instance variables, or methods to use when we use one of the objects? Well, you guys already know when you do something like str1.substring that it's going to call the substring method on str1. But how does Java know that? How does the string class know what str1 is? That's kind of what we're going to be looking at today. So, working inside the class. Pretend for a second, close your eyes, pretend for a second you're working at Oracle or Sun Microsystems or one of the companies that maintains the Java core code, and you're writing the string class. And you want to go ahead and call the length method. You want to determine the length of a string. If you're writing length, the length method yourself in the string class, how do you know which string you're referring to? That's where this comes into play. So it says once the object has, you can open your eyes now. Once the object has been created and we call one of the object's methods, the flow of control shifts to the class. Once we are in the class does not know the object's name since it was created outside of the class. All the class knows is that it is working on the current object, the one that made the call. Again, if somebody were to say str1.length, Java knows that you're working the length method on str1. But what does that actually look like in the length method when you're writing it? That's the question. Java uses the keyword this to refer to the current object when working inside the class. So, for example, let's say you have str1.length or something like that. If you're actually in the string class and you're writing the string class, public class string, inside of the length method, the name of the object that calls the method is referred to as this. So when I say str1.length, what is this? This is str1. If I were to say str2.length, what's this? str2. This takes on the object that calls the method. This is just a, an alias for the object that calls the method, essentially. So Java uses the keyword this to refer to the current object when working inside the class. All right, if you would like to follow along, which I'd recommend, there is a link on the Google Classroom that says 5.9, this keyword. And you'll notice we're kind of jumping around, and again, it's because I thought you needed to know about this before we could do any more of the inheritance stuff. So that's why the section numbers are a little strange, but you might want to click on 5.9 so you can look at the code. You'll notice that the code on this website to start out with in this active code window looks very similar to classes that we've written in the past. There's a class person that has some instance variables for name, email, and phone number. Pretend you're keeping like a phone book or something. You need to have all that stuff. The constructor looks relatively the same, except usually we would just write name equals the name, or name equals n, or something like that. But now you can see that this has been put in front of name. Technically, Java is always doing that behind the scenes. Whether you put this or not, Java is appending this to your instance variable names. So it's saying change this object's name to the name, or change the other object's name to the name. Java's always appending it. So you'll see that there's accessor methods that look relatively the same as usual, except this has been appended in front of the instance variables names down here. Instead of just return name, it says return this dot name. Is it necessary here? No, but I'm showing you that you can do it. It's a little bit redundant, but it just says get this object's name and return it. The mutator methods look relatively the same, except that For the mutator method, it says this dot name equals the name. Again, not necessary, but Java is actually doing this behind the scenes. It says change this object's name to whatever the local variable the name is. And the toString method looks relatively similar as well. It says return name plus a space plus an email plus a space plus a phone number. Again, this is not required here, but Java is actually technically adding that on anytime you see that, any of the instance variables inside of the class. Now, I did open up this visualizer to kind of trace what's going on with the code. You might want to follow along with my screen here for a second. I was just going to kind of walk through step by step what's happening. The first line that happens in the main method is that person P1 is attempted to be instantiated. On line 31 there, when I say person P1 equals new person, what method is being called? Constructor, very good. I'm turning this on. You guys are going to fall asleep. Person P1, the constructor is being called. So program flow goes to the constructor. The main method is temporarily paused while the constructor does its job. What does the constructor do? Well, the name of the method that called the constructor is P1. What is P1 right now? P1 is this. P1 currently has no name, no email, no phone number. They're all null, but Sana was sent in for the name. What is going to happen is this name is going to be set to whatever the local variable the name is. So hopefully we should see the name becomes Sana. Is that true? Indeed it is. The name becomes Sana. And then that's the end of the constructor. Then when we go ahead and print out P1, when I print out an object, what method is being called? The toString method is being called when I go ahead and print out an object. So implicitly, even though I didn't write P1.toString, we know that when we print out an object, the toString method implicitly gets called. So up inside of the toString method, it's going to go ahead and print out the results. Well, excuse me, it'll return the results of the name, the email, and the phone number. Which object? Well, P1, this object. Since P1 is calling toString, it's going to print out the result of P1's name, phone number, and email. Or name, email, and phone number, I should say, in order there. And then the same thing kind of happens for P2, and it's just using this. Now, in these cases, we don't need to use the keyword this, because there's no confusion between instance variable and parameter. But I can tell you that 2 years ago, I had students all write their constructors something like this, because it was very in vogue. I would have all students do something like string name, string phone, string email. Let's say those are the names of the instance variables. Inside their constructor, they would say this name equals name, this dot phone equals phone, this dot email equals email. I would have every student write their constructor like that, where the parameters were the same name as the instance variables. Why? It was like the style guide 2 years ago. No joke. That's how quick this stuff changes. Now they say don't do this anymore. Just say string n, string p, string e. But you could do this. In this case, you would have to do this because you name the instance variables the same as the parameters. So you would have to use this to specify which one's an instance variable, which one belongs to the object, and which one belongs to the method. In this case, you can clear it up. This dot name belongs to the object. Name just belongs to the method here. But if you wisely, like he said, imagine, what did he say? Imagine you're smart enough? What did the guy say in the video? Suppose you're smart enough. So if you were smart enough to do all this and just name it string n, string p, string e, you technically would not need to use this. But even if you don't put it, you know who is going to implicitly put it there? Java. The compiler is implicitly putting it there just to specify, hey, we are talking about the instance variables for this object. Okay, I'm going to be done with the visualizer there. Let's move along. It said use of the keyword. This keyword can be used to identify instance variables. You can specify, am I talking about an instance variable or am I talking about a parameter if there's any confusion. You can call class methods from within the class. And the syntax is always just this dot whatever. Technically, let's say for a second we're dealing with like a right triangle class. Let's say in the right triangle class there's a method like hypotenuse. Something like that. And then let's say somewhere else in, I know that's a right brace, there we go. And then somewhere else in the class, let's say there's a method to get the perimeter. Well, inside there I could say something like return leg A plus leg B plus, and technically I could say return, do this dot hypotenuse. Do I need to write this dot? No, not technically, because there's going to be no confusion over that hypotenuse method versus some other hypotenuse method. Yeah, Ian? Oh, was that your? But I don't know. Tomorrow we might see a class where you inherit a method that's also named hypotenuse. And how do you say I want to use this hypotenuse method versus the inherited hypotenuse method? You could use this dot. Yeah, Jack.
So like, the reason this is the things are named the same, so if you theoretically know this dot,
Correct. I think, did we not look at, when we did the array list free response practice, did somebody have a question that had a bunch of thises in it? Somebody had that. Ben, you were nodding your head. Did you have that question?
I remember.
You remember that? Somebody had a question that had solutions with this dot in a lot of it. And that's kind of, you don't technically need this dot if there's no confusion, like you're saying. But Java is automatically appending it kind of in the background. Yeah. We are going to need it going forward with inheritance. It's going to help you clarify whether you're talking about this class or the super class. That's kind of where we're going with this. Yes, Ian.
If you were to use, like if you made, like if you did this dot name thing, like name this,
You'd be fine.
but like I just said, it was
Well, it's just no. Did I pull up the Google style guide in here a couple days ago? It kind of depends on what company you're at. A few years ago, like everybody was going towards, hey, let's use this for everything, and now it seems recently it's like, hey, we're not going to use this for everything. It just kind of changes from day to day. I don't question the corporate motives of Google and whatever. I'm not sure why they decided to do that. Okay, going along here. Let's see. I don't like that. I'm moving on. Static methods cannot use this. The reason why static methods cannot use this, static methods don't act on objects. Static methods aren't going to be called by objects. So static methods can act on instance variables, can act on objects, so that's why you would never have a static method that references this. We very rarely deal with static methods, and we very rarely deal with this. So if you saw a static method that had anything to do with this on the AP test, I would be flabbergasted. It's possible, but I would be flabbergasted because we rarely deal with static methods and we rarely deal with this. So again, using the this keyword, it can add clarity. Are you talking about the instance variable or are you talking about the parameter? And it can, and just like it says there, it can be used to distinguish between instance variables and local variables. That's kind of the main use for now. Going forward tomorrow, we are going to see that we have methods that might be inherited with the same name, and we have to go, do I want to call this method or do I want to call that method? Now, there is a similar word to this. No. Those? No. Super. If this refers to this class and this object, what do you think super refers to? The super classes, methods and objects and stuff. And so just going back to my example from earlier. If you have public class mammal, and inside of public class mammal there's like public void, give milk, and then, you know, it's got some implementation. If you go ahead and say public class primate extends mammal, at this point, primate has a give milk method. Where does it get it from? Mammal. It inherits it from the mammal, from the parent class. However, if inside of primate I also have public void give milk, then there's a little bit of complication. It looks like the same thing where we have, before we had instance variables with the same name as local variables. Now we have a method with the same name as a method we've inherited. So how do you specify which method you want to call? This and super and stuff like that. If I'm in the primate class and I want to use this one, I'll do this dot give milk. If I want to use that one, I'll do super.giveMilk.
You don't specify.
If I don't do specify, I'll use this one.
So then you never have to use this.
What if I want to use that one?
Use super, but you don't have to use this.
Yeah, you never have to use that.
Max.
If the superclass kind of gives us the get milk method, why would you have to create a new one in primates?
To specialize.
But why would you?
The way that a primate gives milk is a lot different than the way that a mammal in general gives milk.
Is it a string?
Okay. Yeah.
Bella, yes.
What if you have another class under fragment that also has the same method? How are you gonna differentiate?
Yeah, if you give it.
You can't. Then you wouldn't have direct access to mammals one. You would only super would only. You can't do like super.super. So
Mammals, dots.
only if it's static, it would be tricky. All right. Only if it were static. Okay. So this is just used to refer to the object. Can I give you one more example where you might use it? Here's one more case where you might use it. Let's say you're writing a an equals method to compare two people. Here, this is a good example. Let's say the other person has a name as well, and I want to see if their names are equal to each other. Well, I want to see if the other person's name is equal to what? Who's the other person in this case? For example, if I were to go ahead and to call this method like person1 dot equals person2, obviously person2 is the other person. Who's person1? Person1 is this. Do we see another utility here? So how can I say compare the other person's name to person1? I could do this dot get name. So do we see how that adds some clarity? We're comparing the other person's name to this person's name. You don't necessarily need it there. I could just say get name, but you guys would look at that and go, whose name? I'm saying compare the other person's name to this person's name.
If you input this, would it work?
Only if I just said equals this.
Get name.
Other dot get. Oh, if I did this dot get name dot equals.
No.
If I just said this dot equals.
Both get name.
If I said get name, like wait, tell me what to type, Trevor.
Return other get name dot equals get name.
This would be totally legal too, because Java is going to append this dot in front of it. But would you, hey guys, which one's more readable to you? The one in blue and red or the one in green?
Or this name.
The one in green is more readable to you? Are you out of your mind?
Well, I mean, like,
Before today, this is just confusing.
Before
Yeah.
today. Oh, because we just learned it. Yeah.
Exactly.
Yeah. But I think you can see there's two objects involved. There's the other object and there's this object. And so this just helps you clarify which object you're talking about. That's all this is used for. And I wanted to make sure you guys at least saw it, so then when we're going forward and we're dealing with variables and methods that might overlap in a superclass and a subclass, you know how to access this class's method or this class's instance variable. That's why this is important. It just helps clarify. That's all. Is it confusing? Absolutely. It's used very rarely, mostly in conjunction with inheritance, and I just wanted to make sure I gave you a cursory understanding of it today. I realized we didn't get to the bank account project. I might just run through it really, really quickly with you guys tomorrow at the beginning of the hour, or Friday. But you don't have any homework tonight, except if you feel like, holy smokes, I have no idea what was going on with this or that, then you may want to go back to the this page on CS Awesome and go over it. You might want to watch the video and go over it. You might want to watch my video and go over it. Who knows? And maybe you can program in Notepad.
I understand this